For centuries, cities have grown upward. Towers replaced townhouses. Skylines became symbols of power, wealth, and progress. But today, across Europe, a very different transformation is underway, one that most people never see. Instead of building higher, Europe is building downward. Quietly, methodically, and with long-term intent, entire urban systems are being relocated underground. Not just tunnels or basements, but transport networks, logistics hubs, energy infrastructure, data centers, military shelters, and even public spaces. This is not science fiction. And it is not a temporary solution. It is a strategic redesign of how cities survive the next century. Why go underground at all? At first glance, the idea sounds extreme. Excavation is expensive. Engineering is complex. Construction takes years. Yet Europe continues to invest billions into subterranean infrastructure for three core reasons: resilience, space, and control. Above ground, European cities face hard limits. Historic preservation laws restrict vertical expansion. Population density increases pressure on land. Climate change introduces floods, heat waves, and storms that surface infrastructure was never designed to handle. Underground, those constraints disappear. Temperature is stable. Space is protected. Infrastructure is shielded from weather, war, and even cyber-physical attacks. And crucially, underground systems can be automated, secured, and optimized in ways that surface cities cannot. Helsinki, the prototype underground city. No European city has gone further underground than Helsinki. Beneath the streets lies a vast, mapped network of tunnels and caverns, so extensive that the city officially treats underground space as part of its zoning plan. Below the surface are data centers cooled naturally by bedrock, district heating plants and energy storage systems, underground shopping areas and parking complexes, emergency shelters designed to protect the entire population, maintenance corridors for autonomous systems and utilities. Helsinki does not see the underground as backup space. It sees it as primary infrastructure. And this mindset is spreading. From transport to logistics, cities beneath cities. Across Europe, transportation is one of the first systems moving underground, but not in the way most people imagine. This is no longer just about subways. In cities like Paris, Stockholm, and Amsterdam, planners are developing multi-layered underground logistics corridors. These systems separate passenger transport, freight movement, waste removal, utility maintenance, all within different vertical layers. In some pilot zones, goods are transported by autonomous electric carriers underground, removing delivery trucks from city streets entirely. This is urban automation at scale, silent, invisible, and continuous. The strategic layer, security and continuity. Europe's underground expansion is not purely civilian. Energy grids, fiber optic backbones, and data centers are increasingly buried deep beneath cities. Not for convenience, but for survivability. Underground facilities are less vulnerable to extreme weather, harder to sabotage, easier to isolate during crises. This is particularly relevant in a world where infrastructure disruption, whether from climate events, cyber warfare, or geopolitical conflict, can cripple entire economies. Unlike China, which often builds redundancy through scale and speed, Europe builds redundancy through protection and permanence. Two different philosophies. Same objective, continuity. How automation makes this possible? None of this would be feasible without modern technology. Today's underground cities rely heavily on robotic tunnel boring machines guided by AI, sensor networks monitoring structural stress in real time, autonomous maintenance robots for inspection and repair, digital twins that simulate underground environments continuously. Once built, underground systems are cheaper to maintain precisely because humans do not need to be present at all times. In many European projects, robots already perform inspections that once required weeks of manual labor. The city becomes a machine, layered, monitored, and self-correcting. Europe versus China, two paths underground. China also builds underground, but for different reasons. Chinese megacities use underground space to accelerate density, moving malls, transit, and utilities below ground to free space for vertical growth above. Europe uses underground space to slow time, to preserve heritage, to protect systems, to ensure stability across decades rather than quarters. Where China builds fast and visible, Europe builds slow and invisible. Neither approach is superior. But Europe's model reveals something critical: this is not about spectacle, it is about survival. The psychological shift, living with invisible cities. Perhaps the most radical aspect of this transformation is not technical, but cultural. Future European cities will function largely out of sight. Citizens may walk through parks and historic centers, unaware that below them, energy is being stored. Goods are being routed. Waste is being processed. Data is being secured. The surface becomes human. The underground becomes industrial. This separation allows cities to be cleaner, quieter, and more livable, without sacrificing complexity or capacity. Conclusion: the city beneath the city. Europe is not escaping underground. It is investing in depth. As surface cities face limits, climate, density, energy, security, the future of urban life is becoming vertical in both directions. Upward for culture and identity. Downward for systems and survival. And while most of the world looks to the skyline for signs of progress, Europe is proving that the most important cities of the future may be the ones you never see at all.